all programming languages have structures which are called looping or iteration. These structures allow you to repeat different tasks, and they're absolutely necessary to take your programming to the next level. So iteration is the repetition of tasks, that is, repeating a task multiple times. Python has two main looping structures, the for loop and the while loop. Although they can largely be used interchangeably, there are specific situations where you might want to use one versus the other, and we'll talk about those in just a second. So why do you even need looping? I mean, you could just copy and paste, for example, a task over and over again. So for example, if you wanted to print, let's say, a rectangle on the screen using asterisks, you could just type in one print statement, copy it 3 more times, run it, and then you would have your rectangle. And this works to some extent. The problem is that the above will print a rectangle that is 7 asterisks wide and 4 asterisks deep. That's great, but the above is what we call hard-coded. That is, it is an extremely brittle approach, because what if you don't want a rectangle of that specific size? Generally speaking, you want to give the user options, and that is maybe the user wants a different set of dimensions. But because this is what is called hard-coded, this can never change. It will always be a 7x4 rectangle. With a loop, you can create at least one dimension here using a variable. So in the first line, we have this variable called depth, and we ask the user for the depth, and of course we change the entry to an integer. The for loop here will run from 0 up to, not including, the depth that is entered. So if the person enters 5, for example, it'll go 0, 1, 2, 3, 4, which is of course 5. And it will print 7 asterisks across, but it'll do it 5 times. In other words, the user here can enter whatever number they want, and the actual depth will change depending on what the user wants. So this code is much more flexible. The user decides what the depth of the rectangle is. Now in this simple example, we only did one dimension. We could create another loop, for example, what's called a nested loop inside the first loop to handle the actual width. But to keep things simple for right now, I just want to show you that at least with a loop, it gives you more flexibility and avoids what we call hard coding. There are many reasons to use a loop, and you'll find in your code from now on probably more of your algorithms or more of your programs will actually have loops than don't have loops. Many algorithms that we're going to talk about require a loop, for example. The number of tasks that need to be completed, for example, varies quite often. So for example, if you're paying employees in a company, each week the number of employees you have may change. If you're an organization of any size, people are hired and fired each week. They come and go. So the number of employees is different. Reading data from a file, for example. The amount of data that you're getting each week may vary, so therefore you need to actually have some kind of repetition. Again, hard coding the actual names of the employees, if you have 100 employees, and copying and pasting that 100 times creates a very, very brittle situation. If you do that, let's suppose you did copy and paste this algorithm to pay employees, and you did it, let's say, 100 times, you're creating a situation where you're going to have a lot of error because you have a lot of repetitive code. If you have to change the procedures, for example, to pay your employees, you would have to change it 100 times because you have 100 employees. With a loop around the payment algorithm, you only have to change it once. Once you change that, you're ensured that it's going to change for every single employee. All 100 employees will be paid the same way. So this is a very, very powerful reason to use loops because it really does reduce errors, and it also improves your code to make sure that you're doing exactly the same thing every single time. Now, a for loop. For loop is probably the most flexible, most powerful looping structure, and it's the one you're going to use the most often. A for loop is best used when you have a specific number of tasks to perform. So for example, you want to print, for example, in the rectangle situation, you ask the user how many times, what the depth of the rectangle is going to be. The user enters 10, you do it 10 times. That's a perfect situation for a for loop. Also, there are a variety of structures within Python that a for loop works extremely well. Strings and lists are the ones that we're going to talk about. There are others, including dictionaries and sets and some other structures. But we're going to focus on strings and lists. if you need to iterate through a string or a list, that's a perfect situation to use a for loop. So let's talk about iterating a set number of times, the first application that you might want to use a for loop. If you need to perform a task a set number of times, use a for loop with a range function. So our example here, it says for I in range, and it says 0 to 10. Now it seems like this would actually do it 11 times because it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you count those numbers, that's 11. But it's a little strange with Python. The first number in the range is inclusive. That means it is included. But the second number in the range is exclusive. That is, it is not included. So in this for loop, this will go from 0 to 9. It will never get to 10. And that is an important thing to remember. It's a common error. And so if you run this code, and I would encourage you to do so in Visual Studio, if you run this code, you will see it goes 0, it prints the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then stops. Okay, so that's an important thing. Also, the important thing, we talked about indenting. It is very important to get your indenting correct when you're dealing with loops. You'll notice the print statement here is indented 4 spaces or 1 tab. That is, as we've talked about, the appropriate indenting for Python. And that also designates what elements are and are not inside your loop. Here, the print statement is inside the loop. If you want the next line of code after the print statement to be outside of the loop, it should be at the same level as the for loop. But if you want the next statement to be included in the loop, it should be at the same level as the print statement. Another situation that you might want to use a for loop, different situation, is iterating a container. And we'll be talking about these in class, and there are 2 main container structures that we're going to be talking about, and that are strings and lists. Now, we have not really talked about lists yet, but we're just going to touch on it now so that you have an idea of how this will work. When we cover lists, you will see we'll be using for loops extensively with lists. A for loop can, in effect, leaf through these containers. So for a string, it can go through each character of the string step by step. For a list, it will go through each element of the list step by step. So here's an example. If I want to iterate a string, let's say the name Abraham Lincoln, if I use a for loop for letter in name and I print each letter, it will literally print each letter of Abraham Lincoln. Now, you might want to say, well, why would I ever want to do this? Let's suppose you want to create what's called a Caesar cipher, and that is you want to shift each letter of Abraham Lincoln by a certain amount. You could do that by simply embedding this inside a for loop, and as you go through each letter, you could actually change the letter to say instead of an A, maybe be a C, or instead of a B, it could be a D. In other words, shift it by 2 letters. Simple example of this, but at the same time, you commonly will be iterating strings. Another application is iterating a list. Now at this point, we probably have not covered lists in class, but they're not hard to understand. A list is simply a collection of things. So in our example here, I have presidents, and we have 3 presidents that are listed here, and I can create a for loop by saying for president in presidents, and then print the president. And as you would expect, that loop will simply print each element of the list, which is, of course, each of the 3 presidents. Again, there are a lot of applications of this, including payroll, for example. As you iterate through each employee, you can actually make sure that you pay each employee because each employee is an element of the list. But there are a lot of applications of this, and we'll go through each of these in turn during class. While loops. Now, while loops are while a for loop is used for a set number of iterations, a while loop is commonly best used when the number of iterations is unknown, and that is when some condition is met. So, for example, when you calculate all employees' paychecks, the terminating condition, and that is when the loop ends, will probably be when you reach the end of the employees. Okay, and so that's a common situation. You may not know exactly how many employees because when the program runs, it accesses the file and then it starts to pay the employees. And as I said earlier, the number of employees each pay period may change. So, each time you run this program, the terminating condition, that is when the loop ends, is going to be when you run out of employees. You may want to run a program until the user enters the word stop, and then the program terminates. Again, you have no way of knowing when the program starts how many times the user is going to execute this code because it's up to the user. But at the same time, this is a perfect situation for a while loop. And then lastly, we may do an example in class where you have some kind of algorithm and you want to run this algorithm until you reach some kind of a situation, and that is where the error, for example, drops to an extremely low level. This is a more advanced use of a while loop, but it's pretty cool. And that's another situation where you might want to use a while loop. So here's an example. Let's suppose you have a program that prints a daily affirmation that makes you feel good in the morning, okay? And you know, each day may be different, and that is that one day you may feel like it's a great day and I only need one affirmation, and some days you're having, you know, a tough exam or something like that, and you might need a whole bunch. So the program here sets a variable called another, which is going to be y, and that is basically we want to run another time. That's kind of what that means. And then you have a while loop. And you say while another is equal to y. Now we've set another equal to y already, and so it's going to print at least one time the word awesome. You are awesome. Then it gets to a prompt, and it says continue. And if you run this, you'll see this is how the code will execute. You are awesome. Do you want to continue? Say yes. You are awesome. Do you want to continue? Say yes. And you keep going until at the end you say, okay, I'm good now. And you say no. Or N. That means that the code is going to terminate because the terminating condition has been reached, and that is another is no longer equal to y. Okay, so that's one application of a very simple application of a while loop. Notice that unlike the for loop, there is no set number of times this loop can run. The while loop can run 100 times or one time. It will always run one time, by the way, given the way we have this set up. But at the same time, it can run as many times as you want. The user can choose to see the message any number of times, and the loop only terminates when the condition is met. That is when the variable another is no longer equal to y. You'll notice the symbol here for not equal to in Python. It's an exclamation point with an equal sign. A little different than maybe what you expect, but that is the terminating condition, and that is when we actually end the loop. Now, this is kind of interesting. Because there is a while loop, you can reach a situation which is called an infinite loop. An infinite loop is a loop that never ends. And you probably will code it. I know I certainly have many, many times. It's nothing to panic about because it's part of actually the debugging and program development process. It commonly occurs with while loops, not so much for loops, but with a while loop, you have a while loop that never reaches its termination condition. That is, you have a situation where the loop can never terminate. So here's an example. We have this variable another, okay, and we set it equal to y. And then we have a while loop, and we say while another is equal to y, print you are awesome, just like we did last time. But you'll notice inside the loop never changes the variable another. Unlike the previous time, if we go back to the other time, you'll notice another has an opportunity to change because we prompt the user, okay? But here, we've taken that out. And now we never have a situation inside the loop where the variable another can change. So another will always be the value of y. So therefore, since it never changes, the termination condition is never reached. So therefore, the loop will never end. This is a common problem and debugging issue. But you know, in VS Code, if it happens, don't panic. There is a break. You can hit a break key and it will actually stop the execution of the program. By the way, this is something that you may not know. Here's the quick trivia question. What was Apple's mailing address until 2017? And if you want to think about it for a second, you can pause the video, and I will actually give the answer now. The correct answer is it was actually one infinite loop in Cupertino, California. So that was kind of a nod to the programming structure. That's kind of a cool answer and a cool address for a very, of course, prominent corporation.